Hello. Today we're going to be working in BC Calculus section 5.2, natural logarithmic functions. We're going to be doing integration. So keep in mind that whoever the sub is today can stop or pause or rewind. So if I'm going too fast, feel free to ask the sub to pause the video so you can get caught up. So today our rules that we're going to be using will be the antiderivative of 1 over x dx. If I were to think about our rules that we had before, if I have 1 over x, that's really x to the negative 1 power. And if I were to try and use my power rule, I add 1 to the exponent. That would be negative 1 plus 1 would be to the 0 power divided by the new exponent. I would get a 0, and we can't do that. So we have to have a special property, and we have logarithms. So if I have the integral of 1 over x dx, I would just get the natural log of the absolute value of x. And we have that absolute value in there because, remember, we cannot take the natural log of a negative number. So these are our properties that we're going to be dealing with today. And then more specifically, or more generally, the integral of 1 over u du is equal to the natural log of the absolute value of u plus c. We've got a lot of different examples today, so just kind of stick with me here. And here we go. Example 1. If I just have the integral of 1 over x minus 5 dx, again we're using substitution where I'm going to let u be equal to x minus 5. And I continue finding du, which is just going to be dx. So substituting in, I'm going to rewrite this as 1 over u du because dx is the same as du. And then just apply my logarithm rules. So I get the natural log of the absolute value of u, don't forget plus c. Now don't forget at the very end you still have to substitute in for u, so I get the natural log of the absolute value of x minus 5 plus c. And that is my answer. Okay? That's just a real basic answer, or real basic question. So they will progress as we go, a little bit more difficult. So looking at this next integral, example 2, I have the integral of x squared over 3 minus x cubed dx. So again, I'm going to start as what we have been doing. I'm going to let u be equal to 3 minus x cubed. That's my denominator. So then my derivative of u is going to be negative 3x squared dx. So I'm looking for negative 3x squared and dx. I'm looking for all of that. And if I look up here, I'm missing a negative 3 for my x squared dx. So there is my du. So that means I need to put a negative 1/3 out front. So that's my du. There's my u. So what I really have then is going to be the integral. Let me write it down here. Negative 1/3 integral of 1 over u du. And then I'm going to just do my anti-differentiation there. So I get the natural log of the absolute value of u, don't forget plus c. So then I get negative 1/3 natural log of the absolute value of 3 minus x cubed plus c, and there is my final answer. Get a fun little pin out here to circle it. Okay, example 3. Now, when you start doing all your problems, you're just going to have to realize that just because you have a fraction doesn't mean you're going to be using natural log. So I look at this and I would think of this problem as rewriting it as 2x. Since I have a radical, that's 9 minus x squared to the 1/2 power, bringing it up to the numerator, it would be negative 1/2. So this is really not a natural log problem. So this is just a normal substitution. U is equal to 9 minus x squared. Du is equal to negative 2x dx. And I look up here and I see I have, oh wait a minute, I wrote the problem wrong. Whoops, caught it. You guys were thinking I was not going to catch that one. Okay, so I need to erase that. Okay, so now that I've got the problem written right, I have negative 2x dx right here. I've got my x dx. I need a negative 2, so that means I need to put a negative 1/2 out front. So I have a negative 1/2 integral. Then I have my u to the negative 1/2, and then I have my du. And then I am going to do my anti-differentiation, add 1 to the exponent. That would be u to the positive 1/2. Divide by positive 1/2 is the same as multiplying by 2 over 1. Don't forget your plus c. I'm looking here and those 2's will cancel, so I get a negative. Square root of u plus c is basically what I have, but don't forget to substitute in your 9 minus x squared. And there's my final answer. Okay. Maybe I should be putting equal signs. I don't know. Example 4. Looking at example 4, if I were to sit here and think, let's let u be equal to x times the natural log of x squared, I would have to do the product rule. That's going to look worse than what I have, so not going to be a good choice for that one. Sometimes we need to look at the fractions split up, like that. So then this is a more complicated looking fraction, the second one. So I'm going to look at that and say, well, what if I let u be equal to the natural log of x squared? So then my du is going to be my 1 over x squared times my derivative of my x squared, which is 2x dx. So if I look at that, my x's can reduce, so I really get 2 over x dx. Now look right here. I already have right there my 1 over x dx. So I could really put in, multiply this one here by 2, which means out front I need to put my 1/2. So now combined, those blue arrows, that's my du, 2 over x dx. So I'm going to rewrite that as my 1/2 integral, then I just have 1 over u du. Well, we now all know that the integral of 1 over u is a natural log of the absolute value of u plus c. So I get 1/2 natural log of the absolute value of, now this looks really strange, the natural log of x squared plus c. There's my answer. Okay, example 5, very similar to what I just did. You might want to think about splitting up your fraction. The integral of 1 over x to the 2/3 times 1 over 1 plus x to the 1/3. Whoops. I'll let you and your study buddy work on this together. If you would like to pair up with the person across the aisle with you, work on this problem and think about maybe letting u be the most complicated denominator. So I'll give you a couple minutes to work on that. So if you would pause the video at this time. Okay, just to kind of make sure we've all got the same answer, I let u be my 1 plus x to the 1/3 power. So my du would be my 1/3 x to the negative 2/3. I took this right here, this x to the 2/3 that was in the denominator, and I moved it so I could see that I had x to the negative 2/3 in the numerator. So then I could see I needed to multiply that variable by 1/3 so that I would have my du as my double underlined right there. So that means I needed to multiply by 3 out front to make that equivalent. So basically I have 3 times the integral of 1 over u du, my final answer, 3 times the natural log of the absolute value of 1 plus x to the 1/3 plus c. Alrighty? Okay, moving on now to example 6. Example 6, making sure I have the problem written down right, which I do. I would look at this one right here, and the whole denominator, I'm going to let that be equal to my u, 1 plus the square root of 2x. And I'm going to rewrite that instead of square root of 2x, I'm going to put 2x to the 1/2 power. So then my du is going to be equal to my 1/2 times my 2x to the negative 1/2 times the derivative of the inside of the parentheses, which is 2 times my dx. Now looking at that, those 2's right there will cancel. So I get my du to be 2x to the negative 1/2 dx. Or I could look at that as say du is equal to 1 over 2x square root of 2x dx. 2x to the 1/2 power is the same as 1 over square root of 2x. Okay, now this is one of those cases where I'm looking back at my original equation and I don't have 1 over 2x dx. Looks kind of strange. Okay, so I'm going to think about this. Could I do, let's cross multiply, square root of 2x du equal to dx. If I get dx by itself, that's not really helped me much. Let's think about that. I would have, let me squeeze it in over here, the square root of 1 over u, and if I substitute in for dx, I get square root of 2x du. My problem is right there, I still have something in terms of x. Now, we had a couple problems like this in the last couple lessons, and we had one of these on the test. So how do I get rid of that x term? Well, I look back at my u right here. I have u equal to 1 plus square root of 2x. So square root of 2x is the same as u minus 1. So I can substitute in for that and say, well, I now have the integral of 1 over u times u minus 1 du. So there it is. Now I have everything in terms of u. So sometimes you have to be creative about getting rid of those x terms. So now I'm going to continue with distributing the u there. 1 over u times u, I would get 1 minus 1 over u, parentheses, du. So doing the antiderivative of each one separately, I would have the antiderivative of 1 is just u, minus the antiderivative of 1 over u is the natural log of the absolute value of u plus c. Now, u is actually substituting back in. I get 1 plus square root of 2x minus the natural log of the absolute value of 1 plus square root of 2x plus c. Now, keep in mind, you usually will not see that answer in the back of the book because 1 is a constant. So they will usually in the back of the book have something like square root of 2x minus the natural log of the absolute value of 1 plus square root of 2x plus c. And keep in mind that these c's are not the same value. That c, that 1 has been absorbed into that c sub 1 value. I call it, remember, the c sponge. Okay? So either one of those answers is really okay with me. You don't have to combine those constants for me. They are equivalent. Okay, so there we go. That was kind of a tricky problem. Let's do another tricky one right here. Example 7. Wow, are we getting through these problems? This is a long lesson. Okay, example 7. Make sure I've got it written right. The integral of x times x minus 2 over x minus 1 cubed. Okay, so I'm going to look here and probably right there I'm going to let that be my u, x minus 1. So my du is the same as my dx. So if I were to go and substitute in right away, I would have the integral of x times x minus 2 all over u to the third du. Well, still, I have some x's there. So let's look back. U is equal to x minus 1 right here. So u plus 1 is equal to x. So substituting in, I would have for that x u plus 1, and then I'd have u plus 1 minus 2 all over u to the third. I no longer have x's represented. Alrighty, so let's see if I can simplify that numerator. I get a u plus 1 times a u minus 1 all over u to the third. And then I would probably go ahead and multiply out that numerator, so I get the integral of u squared minus 1 over u to the third. And then, wow, looking at that, to be able to solve that, I'm going to split it up. And do the integral of each one separately. So this ends up being the integral of 1 over u minus 1 over u to the third. Well, the first one I know is just going to be the natural log of the absolute value of u. And then I have the integral of u to the negative 3 du. That's not a natural log problem. That's just a power rule. Natural log of the absolute value of u minus, then I'd have u to the negative 2 over negative 2 plus c. So I have the natural log of the absolute value of u plus 1 over 2u squared plus c. And then my last step is just substituting in for u. I get the natural log of the absolute value of x minus 1 plus 1 over 2 times the quantity x minus 1 squared plus c. There it is. Okay, next page, example 8. Wow. Looking at that, if I start off by saying let's let u be equal to my denominator, that's not going to help me any because my numerator is the same degree as my denominator. So that's not good. We have a couple choices. Do you remember how to do long division? Where I take x squared plus 1 and I divide that into my x squared plus x plus 1? That is one of the choices that you can do. We just need to change the way this looks. So if I were to look at this, I think to myself, what do I multiply x squared by in order to get x squared? Well, it's just 1. Then I multiply 1 times both of these terms out here in front, so I get x squared plus 1. Now what I always do, instead of subtracting, I always change the signs and then add them. So those cancel, that cancels, and I get an x left. So my problem is actually 1 plus my x over my x squared plus 1. And now I can work the problem. Okay? Now, I'm sure there's some people out there thinking, oh, I have a different idea, Mrs. Mitchner. Can I use it? And my answer is, I'm sure you can. Some people like to rearrange the numerator. Let me see, where do I want to put that at? Maybe down here. Some people would look at that and say, I'm going to split the fraction. And I'm going to write it as x squared plus 1 all over x squared plus 1 plus x over x squared plus 1. Would that work? And the answer is certainly. Okay, so the numerator, I just split up that fraction so that I would get one term there, which reduces down to 1, and then x over x squared plus 1. As you can see, it's the same thing. So yes, you can split the fraction and get the same thing. I need a bigger eraser. There we go. Okay, so I started that problem. Why don't you put the video on pause, and why don't you and your study buddy finish that one? See what you get. Okay, just real quickly, just to see my work up here, I split my fraction, I split my integrand, which you really don't have to do. You can just do it mentally. The integral of 1, down here I just got an x. And then over here on the right side, I have that x over x squared plus 1. I let the u be x squared plus 1. My du is 2x dx. So I had to insert right in there the 2 and the 1/2. So then I would have 1/2 times the integral of 1 over u du, and then my final answer, x plus 1/2 times the natural log of the absolute value of x squared plus 1 plus c. Now, one thing I do want to point out, x squared plus 1, does it really need absolute values right here? Isn't x squared plus 1 already going to be positive? So there are cases where you don't absolutely have to have the absolute values in there because your quantity there is going to be positive anyway. I'm okay if you want to go ahead and just put it down all the time, but if you were to check that answer in the back of the book, it probably would not have absolute values, and that is why. Just wanted to bring that up. Okay, we have another problem. Example 9, I would like for you and your study buddy to do that one. Put me on pause again, and then we'll check the answer. Okay, here is a final answer. This one was one again where you had a u equal to x plus 1. And remember this little 2 right here, if it's not being used as part of your du, it can come out front. And that's what I did with that one. I put the 2 out front, and notice I still had the x left. So I had to come down here and solve for x. X is the same as u minus 1, and substitute that in. So I separated the fraction and then did my antiderivative, and I got 2 times the natural log of x plus 1 plus 2 over x plus 1 plus c. So let me go back and show my work there a little bit. You can pause this if you need to. And there's the final answer. Okay, switching over to some integrals of the 6 basic trig functions. Only a few more problems here. Stick with me. Got about 10 more minutes here of work probably. Okay, we already know these first ones. So if I want to highlight those, we've already done those. The integral of sine is negative cosine, and the integral of cosine is sine. Now, one that we have that's kind of new today is the integral of tangent of x dx. And actually, I think we talked about this one the other day in our notes when we did a derivative of the natural log, I think of maybe tangent. Not real sure. I think we did have that. But let's look kind of at this proof. Down at the bottom of the page it says derive the integral of tangent of x dx. Sometimes I know that some of you like to see where this comes from, so let's just kind of do this. This is the same as, whoops, gotta change pins. This is the same as the integral of sine of x over cosine of x. Okay? So if I were to split this up, I want to think of this one as the integral of sine of x times 1 over cosine of x. Now, in looking at this problem, I would just let u be equal to the cosine of x. Du, the derivative of cosine is negative sine of x dx. Well, when I look over here at this problem, I have sine of x dx. I need a negative. So I'm going to put a negative out front. So now when I go to rewrite this integral, I have negative integral. This is my du, underlined in 2 black lines there. So there's my du, and I have my 1 over u. So I have negative integral of 1 over u du. Well, that's just real basic. Negative natural log of the absolute value of u plus c. So I get here negative natural log of the absolute value of the cosine of x plus c. Now that's one of the answers up there in that black box. The integral of tangent is negative natural log of cosine of u. Now let's think about our natural log properties. Can't this negative be written as an exponent? The negative out front can come up as an exponent for that cosine of x. Well, that's going to be the natural log of 1 over the cosine of x. And what's 1 over the cosine of x? Secant of x. So that's another form of the integral of tangent of x. Either one works. Just memorize it. Or you can derive it, but it would take a long time to derive that every time. Now, I want to also insert another one. I want to show you how we can derive the integral of secant. And I'll be truthful with you. The ones on the left side, the left column, are the ones that are really used the most. Secant of x dx. Well, to derive this one, it's not real intuitive. You have to multiply by 1. So I'm going to multiply by secant of x plus tangent of x all over secant of x plus tangent of x. So as you can see, I've only multiplied by 1. I have not changed it, but who would think to do that? I'll be honest with you. It would take a lot of playing around to figure that one out. So in the numerator, I can distribute that secant of x, so I get secant squared x plus secant x tangent of x. My denominator, secant of x plus tangent of x. So now I'm ready to look at that and say, okay, let's let the denominator be my u. And then my du, we all know the derivative of secant is secant of x tangent of x, and the derivative of tangent is secant squared of x. All of that with a dx. Well, if I look right here, see if you can see my highlighter. All of this right here, highlighted in green, that's my du. That's all that right there. So this simplifies down to the integral of 1 over u du, which is the natural log of the absolute value of u plus c. So that's why I have the integral of secant of x dx is the same as the natural log of the absolute value of, let's see, what was u? Secant of x plus tangent of x plus c. Okay? And the rest of those properties can be proven very similarly to what we just did. So you have a little memorization to do. Okay, last page. These go pretty quickly. If I'm looking at this tangent of 5 theta d theta, I need to find the integral of that. I'm just going to let u be my 5 theta. My du is equal to my 5 d theta. So looking at that, I don't have a 5 d theta, so I'm going to insert my 5 d theta, the 5, and bring out the 1/5 out front. So there's my du right there. Here's my u. So I have 1/5 integral tangent of u du. So now then I have, just applying that property, negative 1/5 natural log of the absolute value of cosine of u plus c, and then just put in your u back in. Negative 1/5 ln of the absolute value of cosine of 5 theta plus c. There's my answer. Okay, what I'd like for you and your groups to do is to do example 11 and 12. Pause the video and then work on that together. And then I will have my answers up here, so when you're ready, the sub will show you what the answers are. Or if the sub just wants to write the final answers on the board, that's fine as well. Okay, finishing this out, example 11. I have a final answer of 2 natural log of the absolute value of secant of x divided by 2 plus tangent of x divided by 2 plus c. And there's my work if you need to see that. And then for example 12. Example 12, I let my denominator be my u. I just had to insert a negative, so my final answer is negative natural log of 1 plus cosine of x plus c. Alright, there you go. That is the end of notes for section 5.2. Have a good day.